Okay, this video is going to be about circles. We're going to start with parts of a circle, how to find the circumference given the radius or the diameter, and how to work backwards and say, okay, if I know the circumference, can I find the diameter? And the answer is yes, you can. The cool thing about circles is it's true if there's a circle under a microscope, like a cell, or a circle as big as like the orbit of a planet, if we pretended it was a perfect circle. All these relationships remain true. So just to kind of see, this is kind of a good way to remember the parts of the circle. If you look, here's the radius. It's halfway across. And if you draw a little R, it can kind of remind you, oh yeah, it's that short little line. Remember, it could go in any direction, but that's one of the radii. Okay? Diameter, same thing. You can write a D for diameter, and that, in fact, draws the diameter. If you look at it, there's two radii. That means plural for radius. Two radii that make up the diameter. And then circumference, you can draw like a C around the circle. Circumference is basically the perimeter of the circle. Just circles think they're so special, they get a special word for their perimeter called the circumference. Okay? A little way to kind of remember this relationship, the radius times 2 will always give you the diameter. The diameter times pi, which we're going to use 3.14 this year, will give you the circumference. So what's the opposite of multiplying? Dividing. So if I gave you the circumference, you could divide by 3.14 to get diameter, divide that by 2 to get the radius. And so we started by introducing this kind of with a chart. And it's not the best math, so let me just make that very clear. This is kind of a little trick to kind of help you organize your thoughts, but what we need to do is we need to get to the equations. But this one just kind of helps you see the relationship. Those of you that are really, really visual, it helps you see it. Radius times 2 gives you diameter. Diameter times 3.14 gives you circumference. So for example, if I tell you that the diameter is 10, you can use that to find the radius and the circumference. So 10 times 3.14 will give you 31 4/10. And then to go from diameter to radius, the opposite of multiplying is dividing. So instead of multiplying by 2, since I'm going backwards to the left, I'm going to divide by 2. 10 divided by 2 is 5. Okay, well that is a weird 5. There you go. Okay, so that's just a really good way to kind of just understand the relationship between the two. But what we need to get to are our equations. And these are given to you on a reference chart. Circumference equals 2 times pi times radius, or circumference equals pi times diameter. And so in class, we kind of talked about FSA whenever we have formulas. FSA. Okay? And that's not an official math term. It's just a way for you to kind of remember whenever you're given a formula, you then substitute, and then you find your answer. And substitute is a math term we want to make sure that we are familiar with. And so FSA, well, that is kind of a little trick, an acronym to kind of remember. You want to know you're going to write the formula, you're going to substitute or plug in the answers, and then you're going to find your answer. So you're going to simplify and find your answer. So, for example, this is a circle. What part of the circle is that? Radius. Okay, so if I want to find the circumference, if you look, I used the table at first. So I knew the radius was 27. So I know I'm going to multiply by 2 to get the diameter, multiply by 3.14 to get the circumference. And guys, these are the notes we took in class, so if you want to follow along with your journal, you can. Okay? Then we kind of tried to move into our formula. So I proved to you that it was the same answer. So this is your circumference equals 2 times pi times r. We used this formula because we were given the radius. If we were given, so here's the radius. If we were given the diameter, we would want to use this formula because it gives us somewhere to plug in diameter. It just makes our life easier, okay? So here I'm going to substitute. So 2 stays 2. It's a constant. Pi, we know, is 3.14. Every time. That's also a constant. Radius, in this case, is 27. Okay? So when I multiply all those together, I get my answer. Now think about it. This is your chart. To find the circumference from the radius, we multiplied by 2. We multiplied by pi. In our equation, to find the circumference, when we were given the radius, which is 27, we multiplied by 2, and we multiplied by pi. So the formula is the exact same thing. Instead of a pretty little chart, we're given this. Okay? All right, so moving on, we're going to kind of move on to area. And the cool thing is you do the exact same thing. It's just a different formula. So area equals pi r squared. We need to remember this is not r times 2. If I had pi times r times 2, can you think about what that would give you? Well, if I look back here, pi times 2 times r, order doesn't matter, we multiply. We're multiplying 2 times pi times r. If I misread that and say that's a 2 times pi times r, that's going to give me circumference, which is not what I want if I'm looking for area. So every time that you see pi r squared, I want you to write it out. Write out the factors, r times r. This means that r is a factor 2 times. Okay? Get in that habit, make your life easy. I might ask you what a quarter circle is. So if you found the area of a circle, and I want a quarter circle, you'd find the entire area and divide it by 1/4. Same thing with a semicircle. If I want half of a circle, I would find the entire area, right, everything inside this shape, and divide it by 2. Okay? So again, we have a formula, so we're going to do our FSA. So our formula is pi times r. Notice I'm just writing it out. This is what it says on your reference chart, pi r squared. But we're going to go ahead and write that out because I don't want to make any silly mistakes. I substitute 3.14, imagine that. Radius in this example I'm telling you is 4, so times 4 times 4. And then you would get your answer, 50 and 24/100. I would work smarter, not harder on this one. Order doesn't matter when you're simplifying, so I would simplify these whole numbers first. 4 times 4 is 16, and then you worry about dealing with that decimal. Okay? A real-world example could be like, how much cheese do we need to cover this pizza? Because remember, it's not always going to say, like, what is the area? You need to understand that in life, sometimes, like if you're painting a wall, you need to understand that's talking about the area. Okay? So if I want to cover this whole pizza, that is the area. So it is a circle. So on my reference chart, I'm going to find my formula. I'm going to write it out as pi times r times r. I'm going to substitute in. Notice, for area, you need the radius. So we're given the diameter. So I use the chart in this example. I know the radius is half the diameter, so I divided it by 2. The radius of the circle is 5. I can use that now to plug it in, or substitute is the correct word for that. I simplify it down and I find the area. Okay? We did some practice problems in class. We kind of talked about how there's some quick reference pages right here. This is given to you on your formula chart. This is given to you on your formula chart. Sometimes if we want to find the diameter, we need diameter to be by itself. So let's say I'm given circumference and I want to know diameter. We want our equation to read diameter is whatever. So we want diameter to be isolated. So meaning we want it by itself on one side of the equal sign. So in order to do that, we take this equation, and I'm going to rewrite this for you. Circumference equals pi times diameter. How am I going to get diameter by itself, or isolated? Well, right now it's being divided by pi, or multiplied by pi. So the opposite of that is dividing by pi. Those will cancel out, or make a 1. So if I divide the right by pi, I have to divide the left by pi. I end up with diameter equals circumference divided by pi, which is where this comes from. Okay? You can do the same thing if you want to find radius. You manipulate that equation, which is what we call it. So I have in pink here circumference equals 2 pi r. That's on our formula chart. We want to isolate r because we want to solve for r. So we would divide both sides by 2 pi. Because right now r is being multiplied by 2 pi. The opposite of that is divide by 2 pi. So those will cancel out. You end up with r equals, or radius equals, circumference over 2 pi. Okay? So that's just kind of a real crash course review of circles. You're going to want to practice that. These were all in our journals, notes taken in class. So hopefully you took really good notes during that section and you have those to reference. All right, this concludes our circle video.